Hey, welcome to my course on how to deploy machine learning models. I wanted to start this course off with a quick intro video to kind of set up expectations and put forth a bit of an agenda on what to expect from this video. And kind of start off with this idea that this is a high level overview. The point of this course is to kind of show you the steps and kind of look at them at a high level, the things it takes to go from a model to an actual production machine learning system. So let's kind of walk through this introduction and give you a sense of what to expect from this course. So what most data scientists learn in university or even in their first couple years of industry work is how to build machine learning models. And these are really, really important skills, but they are not necessarily sufficient. So the way you generally learn it is that you have a Jupyter notebook or maybe RStudio. You build your model from some static data, maybe from a CSV, maybe from a data set from SQL. You pull that data in, you clean it up, you analyze it, you look at it, you build a model, you're really happy with it, and you make predictions. And if you do that really, really well, you know you did well in university, you do well generally at model creation, and you understand that model creation process. But that's not where it ends, unfortunately, in industry. That feels really good to make a great model, but going from a model that works really, really well in your Jupyter notebook to something that's actually providing value from a business is something completely added on to the rest of this, right? There's an entire process that happens after you've created your model that data scientists, I think, can learn, which I will call deploying machine learning. And if data scientists learn how to do that fairly well, I think they can provide a significant amount more value to the companies they're working for and makes them significantly more hireable. And I'm not saying you have to be an expert at all the things I'm going to talk about in this course. You don't need to be a Google level engineer or be a DevOps ninja, but you can learn the 20% of all of these tools or the 50% or whatever that number is that kind of gets you the 80% of the value. I really do think that's within data scientists' capabilities and will allow them to be so much more valuable for the companies they work for. So what the point of this course is to show you the steps that it takes to go from where you have a good model working in a what I would call experimental system, whether it's a Jupyter notebook or something like RStudio, to something that's usable to a company, to something that I would consider a deployed machine learning model. And so, like, why is this a problem, right? Like, why do we care? Why do we not just leave our models in notebooks? Well, generally, notebooks aren't scalable. Unless you work somewhere at Netflix, it's built a large scalable system around notebooks. But at most companies, notebooks don't get productionized, right? Notebooks aren't running in production systems. They're not scalable. They're not really a good medium for pushing code out to a product. They also have large amount of technical debt. Notebooks are amazing for experimenting, for building models, but there's so many issues with them from a technical debt perspective. They're really, really hard to code review in a lot of instances. They can be hard to make sure they're running in the right order if you're not careful. There's just a ton of technical debt where if you're kind of finalized code as a notebook. They also have no connection to a larger product, right? A notebook generally is sitting out on its own and can take in some data and make predictions, but it's not really part of like a larger system or product. And so much of the future of machine learning, I think, is embedding it into exciting products. You know, Google search is a product we all use, and they use machine learning to make it better. And they make it better at scale and basically in real time using machine learning. The other problem with notebooks is they're hard to reproduce. Uh, Really well written code that's well tested, well documented, well containerized is actually pretty easy to reproduce. Code in notebooks can be really hard. Maybe you messed up the ordering like I mentioned before and it was working, but then you saved it and the person goes and runs it in the right order and it's no longer working. Maybe you don't have doc streams. Maybe you don't even do tests because you're not really sure how to test a notebook. They make that hard to reproduce. They're not automated. You know, they're generally not connected up to these automated systems that allow them to run at scale and in an automated kind of ETL. And they have no feedback loops. Since they kind of live on their own, they require humans to kind of maybe update the data that they're fed to be trained on or run inferences, right? They don't have these automated feedback loops where they're getting more data and maybe retraining themselves or pushing new inferences out on their own or a way so they can even get access from the outside without a data scientist having to run these notebooks. Now, there are some companies that have invested in notebooks as a system. Netflix is one of the more notable ones, and I think that's totally fine if you have a company that's done that. Maybe this course isn't for you, but I think those are few and far between, and I really don't think it's the future. I think notebooks are great for experimentation and model development, but data scientists need to learn the skills to move past notebooks. So, what does that look like? You know, once you've done this static data to predictions in a notebook, that's amazing. If you have a model that you're really excited about, that's great. But there are many more steps. Even when you're just looking at a simple production system that I have here. So at the simplest level, the way you produce a model is you get your code out of a notebook and into some Python files. If you're using Python, that's well tested, production ready, documented, it's got logging, got linting, and so we can kind of go on how to write good code. But you get it out of the notebook and you write good code. Then you containerize it in your Docker container so that it can kind of run anywhere. Then you get it in some type of front-end system with maybe using something like Streamlit that's running off of APIs, that's got monitoring hooked up to it, that's hooked up to maybe serverless data processing and model training so it can always have the most up-to-date model. Maybe even do things like A/B testing, get feedback from your users automatically. This is the simplest type of machine learning deployment system you could have, but it's also really, really powerful. If you can kind of, as a data scientist, not get stuck at the notebook phase, but take your code to well written, to containerized, to a front-end application that's hooked up to some cloud type data processing and inference models driven by APIs, you've just gone full stack. Yeah, there's maybe a lot more depth here that you could get into, and there's ways we can get into that. But just to step back here, if you can go to that level, you can get your models in front of users by yourself. You'll have a front end that you can take to business owners, you can take to consumers, you can test it. You can say, hey, in my testing, my model was working really, really well, but for some reason when I'm running it as a front end application, it's not performing well. Users don't really like it. Why is that? And what I found is data scientists, the real value in this for data scientists is they can iterate so much faster. You're not getting stuck by engineering teams having to help you get your code into Docker or write it better or get it in front of an application to do testing. If you can do all of that on your own reasonably well, your machine learning models and predictions will get in front of users faster, you'll get feedback quicker, and you'll be able to make decisions more efficiently. And in my experience and opinion, a lot of what data scientists do is hypothesis testing, right? We have an idea that a model will provide value for our business, and we need to, as quickly as possible, test that the model is or isn't providing that value, and then iterate and make changes based on what we learned. And until you get your model trying to provide the value you think it can provide for the business, you don't know. If your model's stuck in a notebook for months before it can get tested, that's months you've lost that you can't iterate on, right? So I really think there's a lot of value in this course for people seeing kind of the steps it take at a high level and thinking through where they fall in this process and what skills they have and what skills they can learn to learn that entire flow. So I'm excited to dive into this class with you to kind of click into each of these processes to kind of give you a high level overview of what it takes. And hopefully you can leave this course feeling like you understand what does it actually mean to deploy machine learning and the steps and skills you might need to learn to be able to go from just a model in an experimentation system to a fully deployed system that users can interact with. So yeah, welcome to the course, and look forward to having you. See you in the next video.